current will take time to rise with respect to voltage, and even if the naturally the voltage is getting reduced to zero, but the uh, see here the voltage is getting reduced to zero, but the nature of current, it is rising, it is taking some time to rise, attaining maximum, and this is the zero instant of the supply end, this one, but the current is not zero, okay, because of inductance nature. Okay, so that current we have seen in full converter is been bypassed from load to source and back to load, it is coming. Okay, so in that case we find the negative voltage at the output end. We have discussed this very detail in the earlier classes, so again I will not discuss. But in this circuit you can see that the figure number 2a, that initially the inductor has stored the energy with this with this polarity. The upper terminal is positive and lower is minus. Okay, but when the freewheeling action needs to become, the this is the property of inductor, that it will change its polarity and maintain the direction of current as it is. Okay, so it is found that the from L plus, that means the lower potential will become plus. Okay, so if both of them are plus, the lower potential is plus, then which diode will turn on? D1 or D2? If the lower potential because of load inductance is applied to be positive, because the inductance will freewheel its energy, stored energy. So this lower will be positive. Which diode will turn on? And remember that the supply is getting reversed at that time. Okay, the instant which we are discussing, the supply voltage is getting reversed. That means the B terminal is positive and A terminal is negative. Okay, so B is positive and the anode of D1 is also positive. So D1 will be in reverse bias condition, D2 will conduct. Okay, because small a terminal will be negative, so this cathode is negative and anode will be positive. Okay, so I've shown here in figure number 2a that the freewheeling action is happening uh, with the help of T1 was already on, until and unless the current has been transferred to another thyristor, that thyristor will continue to conduct. Okay, so from T1 load and D2 the current will be bypassed like this. Figure number 2a is showing the path of freewheeling. You can see that the supply is been totally disconnected. So that is why we will not get any negative voltage from pi to pi plus alpha. We are not going to get any negative voltage during this interval. Okay, because freewheeling action is happening because of T1 and D2. Okay, and the moment you apply signal to T2, because T2 is in forward bias condition in reverse bias state. So at pi plus alpha, T2 will turn on and T2 will be the incoming SCR. So the current transfer will happen because of T2. Okay. So this will be the direction of flow of current. Okay. From B to T2 load, and from D2 it will be getting back to supply. Again the output is positive. Okay, so this particular circuit is operating in first quadrant. Okay, so this thyristor will definitely work from pi plus alpha to 2 pi. Again the same thing will happen. The next cycle now is positive for and the T2 will be in reverse bias condition. In that state the freewheeling action will be done by T2 and D1. Okay, here like this. Okay, this blue arrow T2 and D1. Okay, so again we will not get any negative voltage from 2 pi to 2 pi plus alpha. Okay, so the output is completely positive, unidirectional, Now the nature of current will depend. If the inductance is quite high, you can show it to be directly a straight line. Okay, the value of VDC in this case is going to be like the full converter. Okay, Vm by pi 1 plus alpha. So you are going to get the full converter output in this case. And by starting itself, I said that semi converter you will find in DC drive speed control application. Okay, so this is single phase. Similarly, you can look out for three phase. So upper arm will have three thyristors and lower arm will consist of three diodes. Okay, so whenever whichever phase voltage is at is having highest instantaneous value, that particular thyristors will be triggered. Okay, so next voltage will be the highest instantaneous value, and in that case, that particular thyristor will be triggered, and output you will get it to be positive. Okay, so that will be the case with three phase. I am not discussing three phase, but you can visualize and understand the three phase as well if you understand single phase. Okay, and this circuit or this converters you had in BTech also. So at last you can summarize. I have mentioned certain point. At last you can give the value of VDC, which is like full converter. Okay. Let us proceed to another circuit, that is dual converters. Okay. Just now we have seen semi-converters. Semi-converters can operate only in single quadrant. Okay, first quadrant. Okay, and we have earlier seen full converters. They operate in first quadrant. Okay, uh, what is the instant of alpha when they are operating in first quadrant? The output voltage is positive. And what is the instant alpha? Full converter, single phase. Okay, the alpha instant is from 0 to 90 degree. Okay, so from 0 to 90 degree, the full converter works as a rectifier in first quadrant, and from above 90 to 180 degree, the output voltage is positive, but the current is negative. That means it works like a inverter. Okay, which instant 90 to 180 degree. Okay, it works in four quadrant. So full converter works in first quadrant and fourth quadrant. Okay, where working in four quadrant means the load energy is being fed back to AC source in that case. Okay, so if you can take the example of DC motor, the DC motor at the output is going to have back EMF. When the same circuit is operating like converter, it will take DC supply as a input, and when the back EMF of the same machine, if the alpha is been brought about greater than 90 degree, then the same back EMF energy can be fed back to source. Okay, so full converter works in two quadrant. Semi converter, just now we have discussed, it works only in single quadrant. Okay, so if you want four quadrant application, that means you need to have two converters connected in anti-parallel position. Again, I repeat, if you want a converter to work in all the four quadrants, in that case you need to have two converters connected in anti-parallel position, as you can see in figure number 1b. Okay, so uh, if you that means if you without any mechanical changeover switch, this can happen. So apply two full converters in anti-parallel position. That means, or it can be connected back to back to the load circuit. Okay, such an arrangement of using full converters in anti-parallel position and connected to same DC load is known as dual converters. Okay, and presently I am discussing on non-circulating type only. Okay, so non-circulating means basically, so this is the three-phase circuit where you can see uh, this one is the converter 1 in single phase, and this one is the converter 2. Okay, and going ahead, this is the three-phase circuit where this is the converter 1 with the thyristor on the upper leg and pth thyristor in the lower leg, and this but one is the converter 2. Okay, converter 2, right? So three phase circuit along with single phase circuit. So you can see in both the cases the supply is changing, but the basic of having two converters in anti-parallel or back to back connected across the same DC load remains the same. Okay, so this is the case. That means we can, if we want to simplify it, we can represent it by single diode at the uh, converter 1 stage and diode 2 at the converter 2nd stage. Okay, V01 is going to be the output of one converter and V02 is going to be the output of two converter. Okay, and we need the firing angle control. That means alpha 1 plus alpha 2 needs they are equal to 180 degree as discussed. That 0 to 90 and then 90 to 180, you can operate the same circuit in two different modes. Okay, so the output of first converter is going to be V max cos alpha 1, another is going to be having the opposite polarity, that is minus V max cos alpha 2. If you rearrange, you get this value, where I have written it to be the controlled firing angle, that is alpha 1 plus alpha 2 equal to 180. Okay, this present circuit is under discussion is non-circulating type, which means that whenever you are giving signal to converter 1, of course converter 2 is in off condition, and when converter 2 you are putting it into the circuit, then converter 1 has to be turned off earlier. Okay, so there is a time lag, we can say, turning on of one converter and turning off of another converter. At least 10 to 20 milliseconds are kept for the switching operation, you can say. Okay, so because of that, none of the potential difference is happening because of the two converters, and the circuit, there cannot be any circulating current in that case. Okay, but if you are making first converter on and now you are uh, converter 1 is operating, and thereafter you want to turn on the second converter to feed the energy of DC load as a rectifier to some AC source. In that case, you need to the first converter will operate, it will operate, and then you want to turn on the second converter. Then before it was being turned off, you have immediately given signal to second converter. So there is a possibility that both the converter for some instant will be on at a time, and definitely there will be potential difference between the two converters, which will lead to circulating current within the internal circuit. Okay, so that is particularly circulating type of converter. Okay, but here we are just taking under discussion the non-circulating type, where we are taking into consideration that the firing instant of both the converters, there is a time lag of at least 10 to 20 milliseconds. The time lag is given between turning on of one converter and turning off of another. Right? So right now we have discussed two circuits. One is semi-converter and one is dual converter, which works in all the four quadrants. Okay. So here we will stop with the discussion on unit number 2, and I will like to continue with unit 3. One of the content, which is very simple content, which you already know also. DC-DC conversion or DC-DC converter. Okay, so DC-DC conversion, as we know, we can have two intermediate stages. Fixed DC can be converted into control DC, you can have one inverter in the mid, and then you can uh, convert that output of inverter uh, into unidirectional circuit, taking one of the rectifier again. Okay, so two stages are there, but the DC-DC converter suggests that instead of having two stages, one of converter and then again of inverter, then one again of converter, you can have a single stage conversion with the help of DC chopper or DC-DC converter. Okay, so uh, the broad classification with respect to voltage level is step down, step up, and then there is a combination of buck boost, and we will be discussing ahead the recently used converter and along with its control circuit. Okay, so first circuit under consideration is buck converter. As its name suggests, buck means the output voltage is there is going to be step down. Okay, output voltage. Input is AC, output is also going to be sorry, input is DC and output is also going to be DC, but with the uh, lowerage in the output. Okay, so you can see that the supply is positive, that is DC, and there is one switch, one diode, one inductor which is kept just increased to load. Okay, so when this switch has been turned on, what happens, the the supply voltage will be applied to inductor, and through load it will be back to minus. Okay, so this will be the direction of flow of current. Okay, when the switch is turned on. Okay, so you can see that the output is equal to Vs. In that case, output is equal to Vs. Okay, output current, because its nature is inductive, it is getting risen up when the output voltage is equal to Vs when the switch is turned on, right? The moment switch has been turned off, basically this switch is nothing but semiconductor switch, specifically MOSFET, which is very popular in DC-DC conversion. Okay, so when the MOSFET is been turned off, you can see that supply and load, they have been disconnected. The inductor energy will be flowing, or there will be a freewheeling action happening with this path. Okay, so you can see that the output is 0 because supply has been disconnected, but the whatever is the freewheeling energy, it is getting reduced. Okay, it has got path and the freewheeling diode, and it is being circulated within. Okay, but the supply has been disconnected in that case. Okay, so we can have that T on is one of the time, and when there is a off pulse, T off is that time. So complete time period will be T, that is comprising of one on signal and one off signal. Okay, so this is the nature of output voltage and output current, right? Okay, so you can take 1 minute to read it out what is being discussed. Is been written with the direction marked. Mode 1, when the chopper is on or DC-DC converter is on or MOSFET is on, this is the direction, and when it is been off, this is the uh, freewheeling path. Just take a minute to read what has been discussed. Okay, moving ahead, let us see what is the amount of or the generalized formula for buck converter. Okay, so this dotted line is giving us the notation of average value. Okay, so time period T is one on cycle and one on pulse and one on off pulse. Frequency will be 1 by T. Average value of output DC will be considering one time period, that is 1 by T. We are going to integrate for one time period, but as we know that we have the on signal for T on time, so that is why we are integrating from 0 to T on time, Vs into dt. Okay, so Vs will be taken out to be common. Integrating T will dt will give us T, and after putting the limits, that is T on minus 0. So T on will be the numerator, and this T we are bringing it into inside. So T on by T is nothing but the duty cycle del. Okay, so the formula becomes V0 is equal to del into Vs, where del is the duty cycle T on by T. Okay, so load voltage will be definitely controllable one when the duty cycle is varied from 0 to 1, and of course the output voltage is going to be less than the input voltage, right? So this is the buck converter. The second circuit we will be discussing is the boost converter or step up converter. Okay, where the output is going to be more than the input DC voltage. Okay, so you can see here that the position of inductor is being changed, switch position is being changed, and diode position is also being changed. Okay, as compared to earlier circuit. Just a minute. एक फैन लगाओ थोड़ा सा स्पीड कम ये खा लो ना भैया the inductor voltage. So when the switch is in the on condition, we can see that the supply is not connected to load. Okay, but during that period the inductor is getting charged. Okay, move the slide ahead so that okay, so this chopper is on. This is the direction, and where the inductor is getting charged continuously. Okay, and you can see the mode 2 operation, and of course the this point voltage or the inductor voltage is equal to VL, means the inductor voltage, which is it is equal to supply voltage. Okay, and in mode 2 condition you can see when the MOSFET switch or the DC-DC converter switch is being turned off. In that case the supply is now getting connected to load, plus the inductor energy will also be uh, posed towards the load side. Okay, so Vs plus VL will be the output voltage, Vs plus VL. Okay, inductor voltage. So inductor voltage means L dis by dt. Okay, so this is the operation of boost converter happening in two modes. One, when the switch is being turned on, where the inductor voltage is equal to supply voltage, and the second mode of operation where the switch has been turned off, the output is equal to supply voltage plus the inductor voltage, and the blue mark is showing us the direction of flow of current from supply to load. Okay, let us find out the generalized formula which will give us the value of the amount of voltage that has been stepped up. Okay, so here we find that initially the energy stored by inductor, so stored energy is equal to Vs into Is into T on up to the time you are keeping the switch in on condition. So for that much time the energy will be stored in the inductor, represented by W1, voltage, supply voltage into supply current into T on. Okay, and during turn off time the energy will be released from inductor to the load. So the released of energy during turn off will be V0 minus Vs, of course, definitely into Is into T off time. Okay, but we know that in case of lossless condition, steady state condition, these two energies stored and released will be equal. And in that case, if you make a rearrangement, you get V0 is equal to Vs 1 minus del. Okay, there is a small rearrangement there, that you are uh, dividing the sides by uh, t. Okay, so you get the formula V0 is equal to Vs upon 1 minus del. Okay, 1 minus del. So for example, if you keep the value of del to be zero point 0.2, for example, so 1 minus zero point 0.2 will give you 0.8. Okay, so 1 by zero point 0.8 is how much? 1 by zero point 0.8. 1 divided by zero point 0.8 will give 1.25 times the supply voltage. Okay, for example, supply voltage is 100. So 100 into 1.25, that is 125 volts. Okay, so voltage will get stepped up with this formula. You keep the value of del, that is T on by T, anything. For example, the value of del is 0.5. So 1 minus 0.5 means 0.5, and in numerator it goes, it becomes twice. Okay, so output voltage will be twice of supply voltage. Okay, so this is the formula for uh, boost converter. Okay, the next circuit which can be discussed is buck boost, but I will stop here because this we will discuss uh, after your written test which you have. But we'll continue with buck boost converter. Okay, now I feel that we should have one or two numerical on this, so that uh, and you can this formula based numerical we have. Okay, so this is the problem on DC-DC converter, where the uh, input is given out to be 230 and output is 150. That means it is a step down chopper. Okay, the moment you get an idea of step down chopper, just put the formula of step down chopper. V0 is equal to del into Vs. Okay, so uh, you need to find out the on time where the frequency is given. Okay, so the moment frequency is given, the total time period can be calculated by 1 by f. So you get the total time period to be 2.5 milliseconds. Okay, so del can be calculated where del will be equal to output voltage by supply voltage, which is 0.65. Okay, so 0.65, then you have the value of t. The turn on time can be calculated, which comes out to be 1.63 milliseconds. Okay, total time period is 2.5 milliseconds, and if you keep this switch on for 1.60 seconds, you will get this happening. You will get the output to be 150. The input is 230. Okay, so this is related with step down chopper. You can just read out the next question. Okay, so next question is based on step up, where the supply is 200 and output is 600. So the moment you get it, you can just put the formula V0 is equal to Vs upon 1 minus del. Okay, and non-conducting time is given out to be, means t of time is given 100 microseconds, and you need to find out the required pulse width, that is the value of del. Okay, so uh, these are the data which has been mentioned in the question. Okay, and you need to find out the value of del here. Okay, t on, sorry, required pulse width means t on time. Okay, so del can be calculated with the help of this formula, because you have the value of output and supply. So del can be calculated, which comes out to be 0.667 as per the data. Okay, and del is equal to t on by t. T on we need to calculate. T can be treated as T on plus T off. So del is 0.667. T on we need to calculate, and T off is 100 milliseconds. So with the help of this, you can calculate the value of T on, that is 200 microseconds in this case. Right? One last problem we'll discuss. Third problem. Again, the supply is 230, frequency is given, output is 160, and you need to find out the conducting and blocking period, that is T on and T off period. Okay, so दिस इज द डाटा गिवन. फ्रीक्वेंसी जैसे ही दिया है तो आप टाइम पीरियड निकाल लीजिए. सबसे पहले स्टेप डाउन हमें दिख रहा है, तो स्टेप डाउन का फॉर्मूला लगा लीजिए. और टी ऑन बाई टी मतलब 1/t तो है हमारे पास, फ्रीक्वेंसी दिया है क्वेश्चन में. तो फ्रीक्वेंसी तो फॉर्मूला थोड़ा सा मॉडर्नाइज हो जाएगा. V0 जो है इक्वल टू F इंटू टी ऑन इंटू VS. ओके, frequency is known, supply voltage is known, V0 is known, we can calculate the value of T on. So T on comes out to be 695.65 microseconds. Okay. Similarly, the T off can be calculated. T off will be equal to total T minus T on. तो T on तो अभी मिला 695, उसमें से जो है 1 मिलीसेकेंड्स माइनस होंगे, तो 304 जो है वो आपका ब्लॉकिंग टाइम है या फिर टर्न ऑफ टाइम. Right? So I think the numericals are quite easy, you can do. So we'll stop with the discussion here, and whenever we meet in the next class, we will be discussing the buck boost converter, and then we'll go with some advanced converter, DC-DC, that is buck converter and all, with modern control methods in it. Okay, so in unit 3 you will have a buck boost converter. Okay, so either the buck will be asked or boost will be asked, and along with one numerical. So are you comfortable with unit 3? So now the questions means the portion will be very less with respect to unit 3. So just prepare both the circuit, either of the one will be asked. So present the answer properly with circuit working and the expression of output voltage. Okay, and numerical as discussed will be related to that. Data will change, but of course it will be formula based only. Okay, then unit 1 we have discussed all the contents which are there in the syllabus. So my suggestion is that you at least try to properly read the SCR and MOSFET. Okay, SCR and MOSFET. Although I have discussed everything there, but with respect to your now written whatever examination you have, so be at the comfortable end, prepare either SCR or MOSFET, and among the advanced switches, prepare at least IGCT there. Okay, so that will be the unit 1, and then unit 2, just we have discussed semi converter, then dual converter, then half wave full converter, then 3-phase at least half converter. These all circuits we have discussed. So prepare those circuits, and there will be problems on source inductance. So one theory will be there in unit 2 and one problem will be there. Okay, So whatever I have said right now, I will put it in the form of question bank and post in the classroom. So please refer that and prepare for advanced power electronics as a written test. Okay. Is it clear what I said? We put the question in the form of question bank in the classroom. For that I will go. Although considering unit 1 and 2 we have discussed everything in detail, but still I'll concise some of the topics so that you will be in a comfortable position to write in the examination. Okay. So thank you from my side. You can leave. If you have some query, you can leave the class. You have studied that current will take time to rise with respect to voltage, and even if the naturally the voltage is getting reduced to zero, but the uh, see here the voltage is getting reduced to zero, but the nature of current, it is rising, it is taking some time to rise.